Yeah, this is the outline. So I'll start with saying that Python 3 is a better language. I think that most people agree with that. One example, this is my name on my card, and there's a O with a caret at the top that wasn't there when I was typing it in. And of course, this is not an isolated problem. I took a screenshot of Fedora backtracker looking for Unicode decode error, and at any given time there's hundreds of bugs open that come just from Python 2 problem with encodings. And this is a problem that is basically solved in Python 3 to a large extent. So Python 3 is better, and still people are using Python 2 because, well, because of the incompatibilities that are hard to jump over. But the developers of the Python language and of the Python standard library have been working for the last few years, as always, making new releases. And all this work has gone mainly into the Python 3 branch. And the Python 2 branch is in backfix, well, not backfix only mode, but it's not really getting any new features. And Python 2.7 is going into maintenance mode, backfix only mode next year. So it is an unfortunate situation. And well, it would seem that natural to assume that people would work on converting libraries from Python 2 to Python 3. And this is more or less what people expected in the beginning, that the conversion from Python 2.5 or 2.6 to Python 3.0 would be like any other change after a release of Python. Maybe it will be a bit slower this time, but it should work. But this hasn't happened. And then after a few years, people started talking about reaching a critical mass, where if enough libraries are ported, then people will start porting other libraries because they will feel the pressure to do that. And then people formulated a variant of this theory saying that, well, if the important ones are ported, we don't actually need to port all the tiny libraries. So in the scientific software world, with Python, there's NumPy, SciPy, Matplotlib, IPython. All of them are available for Python 3, and people are still using Python 2 because this theory doesn't really work. Because as long as you have one dependency of how many you have, which is holding you back, then you cannot really switch. And distributors, like well, people who do releases, people who do Linux distributions, they're not going to package some alpha quality Python 3 port. They wait until the Python 3 version is supported. And this means that still we are held back. So I think that if you are an author or maintainer of a library in Python 3, you should really think about, if you haven't done it already, releasing a supported Python 3 version, because you might be holding back other people even if you don't see the immediate need right now. And well, this talk is about how to do it. It's an introduction. And here I put porting on the previous slide in quotation marks, because I don't think that it's really much of a porting as of updating to a new version. There are a few approaches, and picking the right approach is what will basically determine the amount of work you have to do. So the first approach I would call the insane approach is to fork your code, have two trees, and then apply patches by hand to one and then to the other. So basically do what CPython is doing. I think that this is, of course, possible, but really a lot of work and should be avoided. The second approach is the approach that is what is recommended right now. Have one code base that is, has compatibility hacks so that it works with all versions that it must work with. And this became possible. It was really hard in the beginning because the difference between Python 2.5 and 3.0 was pretty big, but now the difference between Python 2.7 and 3.3 is much smaller. So this approach works really nicely. And then there is the original porting approach recommended when Python 3 came out, that before installation, at some point in time, you run 2.2.3 over the code base, and you apply some set of fixers to make your code work on Python 3, if you're starting with Python 2 code. And using 2.2.3 is still relevant because it helps to achieve the second type of compatibility. And the fourth type here is, fourth approach is actually having Python 3 code and making the compatibility the other way. And this is not very popular, but possibly because there isn't really that much code that is Python 3 only. But maybe when there is, people will start using this approach. And so this talk is about taking a modern, making code work with modern version of Python 2 and modern version of Python 3. And if you care about Python 2.5, then this is going to be very painful. Even Python 2.6 is quite a big problem, and Python 3.2 is also a bit of a problem. So if you can forget about those old versions, then that's great. And well, Python 3.0 and 3.1 weren't really that popular, and they're not a problem because of that. It's, well, good. So people view the difference as, almost full compatibility in between Python versions and then this big jump. But it's more like, well, there's always something you need to update after each release, some new features, maybe something is deprecated. And you also have other libraries, whatever, and they all make releases, and people try to have compatibility all the time, but every once in a while you need to adapt or your code bitrots. And I mean, if you do it in small steps, then it's much easier than doing it in a big jump. So I put here a timeline of some features in Python. So the U prefix has been missing for a while, but now it's back. And it's great for having a single code base that works on Python 2.7 and 3.3. We have the print function, which is available in some form. I mean, either directly or you import it from the future in basically all Python versions right now. We have various other things like advanced formatting, which are also available in all versions. And then there are things like advanced formatting without actually having to specify the index in the placeholder, which are available in 2.7 and some versions of Python 3. And this means that, well, for example, as far as formatting goes, the new formatting, the version between the difference between 2.6 and 2.7 is bigger than the difference between 2.7 and 3.3. And well, there's a bunch of other things like that. I don't know, set literals, set comprehensions, dictionary comprehensions, some things in the standard library. And well, this all means that making the jump from 2.7 to 3.3 is, well, not that bad. And there are some things that are, I mean, the free version of the Python 3 version of the standard library is starting to grow more and more things which are not available in Python 2, and they will not be available. So it is possible that right now is the best time to actually make the switch, because the difference will only grow. Probably nothing new will happen in Python 2.7. Yeah, and of course, some of those features are really amazing, like concurrent features is something that is, well, you can make parallel code by adding just one line or 2 lines to a simple script, and this is something that is incredible. So borrowing from yesterday's keynote, the sine qua non of porting is to use version control. It will be, when you're making sweeping changes over the whole code base by some automatic tooling, you need to be able to roll back those changes or commit them or compare different versions. So you basically always need version control, but here it's even more important. And you need to test suite because it's just impossible to test tree-wide changes in any decent way. If you're working on a feature, then you can maybe just test this feature by running the code in specific settings. But here you want to make sure that all over the tree, your changes didn't break anything. And you want to test it on multiple versions, well, 2.6, 2.7, maybe 3.2 and 3.3. And without doing it manually is very, very hard. And you need to update your code. So the more legacy stuff you have in your code, the more pain you will have. This was, I don't know how many of you were in yesterday's talk about porting the Eventbrite code. So basically, the biggest problem there was the actually legacy code left over from, at least the way it seemed, from the evolution of the code over different Python versions. And there's no way that your library is going to work with Python 3.3 and 2.4, for example. So if you want to support Python 3, just drop the old support code, update syntax, I don't know, use new style classes, and well, make the code idiomatic. So there's Python -3 switch, which tells you about some things, and so it's good to heed those warnings and actually update your code. And it is possible to bring syntax and features from Python 3 to Python 2 by using the imports from Future. So probably everybody knows this, but division makes the division operator always return a real float, so you have no truncation. So to deal with that, you can import this into your code by finding all places where division happens, checking if there are ints, and if there are ints, replacing the division with a double slash and getting integer division, and then adding a from future import division import at the top. And this makes your code work with basically all versions of Python from when the future import was introduced so many Python versions ago.
That's 2.2.
Yeah, so ancient history. And the same is true for print function. And there is a module called feature built-ins, which adds built-in functions like map that returns, or zip that return iterators. You can import from that and use it in your Python 2 code. And those first three are nice because they're local. And basically, you need to adapt the code a bit, but it's fairly safe. There is the absolute import switch. The problem with that is that it also works just on the module, and this is fine, but it breaks running the module directly as a script from the source, because it complains that it's part of a package, and you need to take extra steps to support this. So if your modules are not scripts, they are not called from the command line, that that's fine. But if they are, you need to take extra steps. And Unicode literals turn all strings into Unicode strings, Unicode objects, and well, this is usually the most problematic one because you need to make sure that wherever your string ends up in whatever place, it will be welcome there, that all your functions have support for both for Unicode object and string objects, so it can be dangerous. I'll show an example later where this standard library itself has a problem with Unicode literals. So just to make a small example, there is a stupid program which prints out the MD5 hash of the first argument. And well, it is a Python 2 program. It has just a print statement here. And so I run Python -3 on it, and it tells me that the MD5 module is deprecated, use hashlib instead. And this is something that is that will need to be done by hand because even tools like 223 don't fix this. So basically, you have to do it at some point. And so I took the advice, import from hashlib. And now I have a well, updated Python program runs without any warnings in Python 2.7. And let's say that I want to port it using the Python 2.3 approach. So I run 2.3 on it. I explicitly call the Python 3 version of the module, and it prints out just to the screen, something like that, that the, well, I need to add parentheses here, and this is not very readable. If you have multiple files, then I mean, you get thousands of lines of output. It's not really useful. If you're using version control, you can, without trouble, just overwrite your source files, and you don't need those. I mean, by default, it creates .back files everywhere, which are useless too. And you want to view the difference in something that is a real, I mean, the tool designed for this. So I use Git. So Git diff, it's fairly good at showing all the, I mean, if you have just one print statement, it doesn't matter, but if you have thousands to review, then this is, it works much better. And also there's very useful color words mode that will just highlight what is changed. And you can instruct Git that the .py files are Python files, and it will show it will understand the syntax enough to properly highlight what needs to be highlighted. And if you're reviewing a bunch of stuff, this is useful. So 2.3 has a bunch of fixers, and maybe a fourth of them are stuff that is actually about porting from ancient Python to Python 2. I don't know, apply removes the apply keyword, the keyword function invocations, the accept fixers, adds the S keyword where necessary. The next few are about old things that have been renamed, including funcators. Heskey introduces the in operator instead of the Heskey call. NE is about removing the cute Pascal inequality symbol. There's no literals is about adding prefixes for octal literals. And paren is is a fixer that adds parentheses where they're required by Python 3 syntax, but it really makes also Python 2 syntax, even though not required, clearer. So this is something that you can already apply, and it makes your code work better in the future. Then there's a bunch of fixers that do some of the heavy lifting. And so I talked about absolute imports and print function and using built-ins from the future built-ins module. So those fixers add that. Buffer adds calls to memory view instead of the buffer interface, and tuple params deals with the fact that Python 3 lost the ability to have tuple unpacking in parameters to functions. And well, it works, but it uses ugly temporary names for variables. So you still have to go over the code and change those names by hand to something meaningful. But all those things are things that you can apply. I mean, you can use 223 to show how it might be done, and apply it to your Python 2 version of the code, put in from future built-ins import at the top, and even if you convert the code later on using 223, it is better to have a smaller difference. If you're changing the whole code base and important changes are really buried in the syntax differences for print, then it will be really hard to see what is important. And if you have some bugs, then it's harder to figure out where they happened. So the more you can bring your Python 2 code to the edge between Python 2 and 3, the better. So there are fixers which mainly deal with the differences in the layout of the standard library. And so, for example, reload fixes the call to reload to call imp.reload, and so on. There are a few which actually do some non-trivial work, and that is xrange, which will change all your xrange calls to range calls, and will change all range calls to list from range, from whatever calls. So you really want to have xrange wherever possible in your Python 2 code, and then if you use 223, it will get translated to range, and you won't have the extra ugly cast to list. And meta-class deals with the differences meta-class syntax, but it's tricky to sometimes do the conversion, and this one should always be reviewed carefully. And there are a few which are about prettifying code. I put the Unicode fixer in there. It removes the U prefixes, but we don't need to remove them anymore, and it's actually nicer to keep them because it reduces the amount of change. So now it's set literals changes explicit set invocations changes them to set literal syntax. So this is something that can wait. And I said that Unicode can bring strange problems. And as an example, let's say that we have a class, and the class has a representation method, and it works as expected. But let's say that we add a real Unicode character in there. So this is a Unicode object, but this is a Unicode object with really something that is not convertible to ASCII. And depending on on Python version and the phase of the moon, it's possible that it will blow up like here, and you cannot even print out the object rep now. And So this is something that you wouldn't normally do. Use non-Unicode characters directly in the representation of an object. But let's say that you include some user-specified variable like the name of the object, and then it can easily happen. I mentioned this because if you have Unicode in a rep or a str function method, and it is a normal string in Python 2, then you can print out the representation without any trouble, but you add Unicode literals. And this is equivalent to adding a U before the string, and it stops working. And it stops working in a really nasty way because let's say that you never use the wrapper of an object, of this specific object, but you have an exception, and the object is present somewhere in the call chain. Python tries to print out the traceback, cannot convert one of the objects, it generates another traceback. Because there's no traceback chaining in Python 2, then the original traceback is lost, and you get this useless traceback about not being able to print, not being able to convert ASCII, Unicode to ASCII, and it doesn't even tell you what characters it can convert, so finding the proper place can be, well, difficult. And just for comparison, Python 3 version works with all characters, of course, and you can even use it in the class name if you're inclined to do that. 2-3 is still a viable approach. People don't dislike 2-3 because they said it was too slow, and it's not very fast, but it doesn't really matter because, first of all, applying 2-3 fixers is an ideal computer science problem because you can parallelize it for free trivially. Each file depends only on itself. And what is more important, 2-3 can be run like make. Just convert those files which changed and ignore the rest of the tree. And even if you are working on a large project, you're never modifying more than a few files, so it should be fast enough. And you want to integrate, of course, put the invocations 2-3 directly in the build system, so it gets run automatically. And if you use 2-3 or not, the process is always the same. Apply some changes, test if they work. If they don't work, roll them back, try again, and so on and so on. Things like distutils2 or distribute or packaging, they all support running 2-3 fixers directly without any trouble. You can specify which fixers you want to run, which you don't want to run, and this, well, it's nice and easy. If you're using these utils, then you need to do it by hand. So basically, the idea is to make a build directory somewhere in the source tree, put the converted sources in that directory, and then run the installation from there. And this is something that you have to, well, take from somewhere. I would recommend taking it from NumPy. I just put a link here because I mean the details are. I mean it's pretty simple code that uses OSWalk to walk over the two trees, compare the timestamps, and do the 2-3 conversion or not. And NumPy doesn't actually use 2-3 anymore, but well, they did and had nice support for that. So this was the, so to speak, the old approach, and the new approach is to use the same code base. It works best between 2.7 and 3.3. So basically, apply all those fixes and changes to the syntax that can be compatible between Python 2.7 and 3.3. You mark up your literals with B or U to specify the type, and Python 2 will ignore B, and Python 3 will ignore U, and things more or less work. There are some things that need to be taken into account, and one of the annoying ones is that if you subscript a byte sequence in Python 3, you get an integer, and you get a one byte sequence in Python 2, and there's a trick using slice syntax that you always get a 1 byte sequence. And the big problem is managing all the imports. So there's this fairly ugly pattern of trying to import the Python 3 version and falling back to the Python 2 fallback. And Python 2.7 has some of the modules that are available in Python 3. So maybe you can use imp-reload even in Python 2. The same with I/O. And some of the changes are pretty complex. For example, HTTP-lib is quite problematic because of the split in Python 3. And you can run 223 on the code, see what it suggests, and incorporate this in your workarounds. And the advantage is that everything becomes simpler. You don't need to do anything in the build system. You use the same code directly from the source in all versions. This is nice and faster. So I have about 10 minutes, right? Okay, so I started late, so I'll cut this part short. With C extensions, there's just one approach that's using the same code base because there's no way to translate C code. So if you have C extension code, it will be littered with if-defs all over the place, but there is no way around that. So Python 2.7 has support for package config, or older Pythons have support for the Python config command line thing. So basically you need to extract the flags, and the package config approach is the best because it just returns the flags that are really necessary. And I put a AutoTools snippet here to it will just generate those variables, C flags and libs, and you put them in the make file in the right places, and things should compile. So the changes to the C API mirror the changes made in the Python syntax, and plus a few more things. So those things that are extra that need to be taken care of when porting an extension to Python 3 is that the naming convention for the module initialization has changed. So you end up with something like this. We have a underscore reader module, and so the method, the function will be called init underscore reader in Python 2. It will be called pyinit underscore reader in Python 3. And also the return type is different. In Python 3, the initialization method is allowed to return an error. This is something that you couldn't do in Python 2. It was, I mean, if the initialization of the module failed, there was no way to signal it properly. So basically, all return statements must be changed to return null for error, or return m, where m is the newly created module. So module create is replaced by PyInit module, and there is some extra structure that describes the module. And what is interesting is that this structure has a size field. The size describes how much memory the module needs. And before, in Python 2, the memory was static memory. So it was, if you had multiple, if you embedded multiple versions of the Python interpreter in some external program, then the modules would share this shared memory, and it will be problematic. But now, each interpreter, each instance of the module in different interpreter gets its nice own chunk of memory to manage the data. -1 actually means that there is no such data necessary. And so there's PyInt is gone in Python 3, so the official C porting documentation suggests to replace PyInt calls by PyLong calls, but I find it nicer to use PyInt in Python 2 and PyLong in Python 3 by some ifdefs. Not very nice, but it works. The advantage is that in Python 2 you don't get the long objects which have the extra suffix. A similar situation happened, well, the other way, maybe, with bytes. So to describe it shortly, this is from the official porting how-to. For best compatibility with Python 3, PyUnicode objects should be used for textual data and PyBytes for binary data. So this means that in Python 2, that you use PyUnicode and PyBytes, which is defined by the compatibility header bytes object.h, and you get Unicode and str in Python 2, and str and bytes in Python 3. And, well, things should mostly work. I put up a bunch of links here. The ones that I recommend are the official docs on python.org. They really give good advice. And the Python 3 porting book by Leonard Regebro has nice examples how to manage the conversion. And well, what's new notes are of always always important. And some stuff that is crossed out that is interesting, but it's mostly of historical value. Okay, so thank you very much. The slides are up on the web, and if you have any questions, then please go ahead.